Okay, hello, welcome back. So this is hardware guide. The last part, not the last part. I think probably this is the last part. Okay, so this for this video, we will focus on the power supply, but not for the converter, but for microcontroller. Okay, so this is different from the power supply for the converter. Okay, so usually you have converter, right? So this one is converter. Okay, converter, and then you have a power supply here, plus minus this one. Okay, so this is a converter power supply. So usually it's very large voltage. V in is quite large, and the current is also quite large. And you have the load here. Okay, that is standard. But this is not the power supply for the microcontroller. The power supply for microcontroller is actually here. Okay, so microcontroller, and then you have the input, right? But usually in the block diagram, we don't see the power supply for the microcontroller. The problem is the microcontroller usually use a lot of power supply. Okay, so a lot. Okay, usually for converter we just use one, probably two or three, except for the multi-level multi-level inverter. That one use a lot of power supply, but normally converter use only one or probably two power supply. But for the microcontroller, usually we don't see is the requirement of the power supply, and the power supply needs to be isolated. Like I said before, you cannot just use the same ground. Okay, sometimes you cannot use the same ground. So for this case, okay, so let me explain. For if you use LEM, okay, LV25 or LEM LA55, right? I forget already. This one is the voltage sensor, okay, and this one is the current sensor. Okay, so for this power supply, you need to have two 15-volt power supply. Okay, but this one is also need the same thing, so you guys can share it. Okay, and the power usually 0.1 watt, I think, if not mistaken. Okay, you have to calculate this, but usually around 0.1 watt, same as the LA. So you need to have two power supply for this, and then sometimes, just for your information, LEM and LV, this one, both of these, usually the output is only around 6 volt. Okay, if you use Arduino, okay, something like Arduino, the analog to digital converter is only 5 volt, so should be okay. But if you use this base ADC is 10 volt. Okay, this one is 0 to 5 volt. This one is plus minus 10 volt. Okay, so the problem is this one don't have enough voltage. Okay, if you use it, it's not sensitive, so sometimes you need to have a magnification circuit. Okay, the magnification circuit is actually the operation amplifier, negative feedback, I think, or positive feedback. Negative feedback operation amplifier, just to amplify from 6 volt to 10 volt. Okay, so that is another power supply. For if you have if you use this space, you require to amplify the circuit, you need to have two more power supply. Okay, if you, let me add another. Okay, and if you use the EMCEE EMCE gate driver, Okay, if you use this one, you only need one power supply for all of the gate driver you use. Okay, because it already have isolation, so you don't need to worry. But if you have you use the SCPL 3120, so for this one, each needs power supply. Okay, so you can see here from the sensor voltage or current sensor, voltage and current sensor, so you need two 15 volt. Okay, one 50 volt, one negative 15 volt. Okay, one, this one is another one. Okay, so you already needs two, and if you use power supply, if you use the in amplification circuit, you need another two. One is for negative for 10 volt, and then another one is the negative 10 volt. So this one is negative. So you already need 4 power supply. And if you have the gate drive, also you need one more power supply. Okay, but gate drive usually you need to isolate because you usually can produce noise and can disturb microcontroller. So that is already 5 power supply. And then you have the one power supply for microcontroller. So the total now you need to have 6 power supply. So this one is not efficient. Okay, you need 6 power supply just to control the circuit. So to overcome this, okay, too many power supply, but the this power supply is only around 0.1 watt or 0.2 watt only. Okay, it's quite low. Okay, the power is quite low. So to overcome this problem, so you can go to element 14 and you search isolated through hole DC-DC converter. So this one, you can see here there are a lot. Okay, so basically this power supply, okay, is an isolated power supply, usually something like this. Okay, it's just a small box, I think around same size as your thumb. Okay, usually you supply 5 volt. Okay, it will produce 3. Okay, 15 volt plus 0 and minus 15 volt. So basically you already have 2 power supply. Okay, and this one is isolated. Okay, so you don't need multiple power supply, you just need one power supply here. Okay, and if you have another one, okay, if you have another power supply, the magnification power supply, you buy another one. Okay, so this one you can just share it. Okay, something like this, you can just share it because it will not disturb. Okay, so this one can produce 3 also, plus 10 volt, 0 and positive 10, this one is negative 10 volt. So basically you already solve this problem. Instead of using this one is 4 power supply, you only use 1 power supply. Okay, and if you using EMCE power supply, of course you cannot use this one. Okay, this one you cannot use. Okay, this one is isolated because the gate drive here. Okay, this is the gate drive. Gate drive for EMCE. Okay, so this one, the G and D will be connected to this one. Okay, and this one will connected to the microcontroller. Okay, so this one you can supply using a power supply, another power supply. or you can just share it, but usually they have noise depending on the converter, but you just can share it, okay, with the microcontroller. So this one needs 5 volt, okay. So you should have only another one power supply, okay. So now instead of 6, right, before this is 6 power supply, you only need 2 power supply for the microcontroller. I repeat back, this is for microcontroller. So by using this thing, you can remove that problem. So how to choose? And of course, you have to choose. I suggest for the sensor, like I said before, you need to have 2 power supply, right? So when you have 2 power supply, you have 2 output. Okay, and then output is 15 volt, right? So you have to choose 15. This one 15. Okay, and then the input, usually we choose 5, but this one is don't care, but make sure you choose the standard one. Okay, make sure the same. If you choose 5, another one is also 5. Okay, so you filter this, so you can use this XP. I usually use XP power from the company called XP power. So if you look here, the price is around 40 ringgit. Okay, so this one, the input is let me check first, where is it, I forget. Okay, input is 10 volt. Okay, you can see here, not 10 volt, 12 volt, and the output is 15 volt positive and 15 volt negative, I think. Or wait, so you have to be careful, some of it as positive, and yeah, correct. Oh no, I think this one cannot. I think this one is positive. You have to search for positive negative. This one, let me check first. Okay, so you have to be careful. Okay, you have to look here. You can see this is output 15 volt and negative 15 volt. So I think I choose the wrong filter, but you can just search for this. So you can see here the output is 2 watt. I think 2 watt is enough to supply for 2 sensor, okay, voltage and current sensor or anything. Usually the sensor is only around 0.1 to 0.2. Okay, you have to calculate actually. They have the formula inside the datasheet, but this one is enough. So 2 watt, 15 volt, 0.67, but you have to be careful, 15 volt and negative 15 volt, because you have to supply the sensor with positive and negative 15 volt, and for this one you have to supply 5 volt for the input here. So you can see here the input is 5 volt. So this one is quite good. I suggest you just copy the order number 1021491. You just copy and search here in element 14 search bar, and you can get the component. So this one is suitable for the sensor. Okay, so that is how you find out. You have to be careful, okay, searching this, because this is quite expensive and you have to buy it, maybe 1 or 2. If you need 1, maybe you have to buy 2 for safety, but you need it. So suggest you search carefully, positive, negative, that one, okay, because remember, like I said before, you have positive and negative for the if you use LEM. Okay, and another thing yet you need to be careful is the supply. So if you recall back the supply here, this one is very sensitive. If you buy the isolated through converter here, it's only can withstand 4.5 volt to 5.5 volt. It's very sensitive. So I suggest you add linear regulator 7805. This one is the standard linear regulator. You can just buy it at the top one. They have it, I think, around 2 ringgit something. Okay, you have to add before it. Okay, same as the microcontroller here. Okay, where is it? Okay, this one. So I suggest you put, okay, 7 7805. Okay, if the power controller or supply power, the microcontroller needs 5 volt. Okay, if the microcontroller need 3.3 volt, you have to find, I think for Arduino they have a Arduino power supply. Okay, or not Arduino, I forget the name, 8255, 82, okay. Okay, this one, ESP32 or ESP828622, something like that. Okay, this one requires 3.3 volt, you can see here. Okay, so you can see this one 3.3 volt. So you have to buy at Shopee, they usually have the power supply for this. So that is 3.3, because linear power supply don't have, I think, 7803.3. Okay, 5 volt you can just use 7800, 7805. Okay, linear voltage regulator, same as here. I suggest you put it, because last time I do this, I mistakenly touch the knob of the power supply. The voltage becomes 6 to 7 volt and it damage this, and this is RM50 ringgit, you will lose it. Okay, so I suggest you add this. Okay, so that's it for the gate drive. Okay, sorry, not gate drive, the power supply for microcontroller. Okay, so make sure you prepare for this. Usually in the block diagram they don't show the power supply for microcontroller, but actually it's quite complicated. Okay, you have to be careful with the isolation. Okay, the ground. So this one is, I call it G1 maybe, and not G1, yeah, G1. This one is G0. Okay, G0 is for the microcontroller, G1 is the input for this supply. Okay, and then for the converter supply is different G. Okay, so I hope you can be careful with this. Okay, sorry about this, I don't have my drawing pad actually. This I use my touchscreen laptop, it's not very good. Okay, so that's it, good luck with your design. Okay, thank you.